When analysing flow cytometry-derived multiplex bead array data, perform the initial setup in BeadLogic before continuing the regression analysis in BeadLogic. Here I'll import my FCS files, which include my standards and unknowns. I will then add these files to a group, and then continue to gate on the bead populations to identify the different analytes. Once the correct combination of parameters is selected in order to identify individual populations, apply the appropriate gates and rename the gates to match the analyte name, in this case, particular cytokines. As many of the populations exist in close proximity to each other, one tip is that once the gate has been created, in the plot side drawer, navigate to the Gate List tab and untick the box in the Show column to turn off the gate. This will simply hide the gate rather than delete it, and therefore prevent you from accidentally adjusting the wrong gate. So here, I will continue to gate on each of the populations, and as mentioned, rename the gate with the analyte name, and this naming system will be passed on all the way through the analysis. If the same analysis is performed time and time again, then after initially performing the gating, the gate template can be saved and applied to a selection of files in one go. To save a gate template, right-click on the sample in the File Inspector and choose Template, Gate, and Save Gate Template. If the template is saved from a file that exists in a group, then that group setting will be applied to all future samples to which the template is applied. If the gates aren't named at the time of creation, they can always be renamed in the File Inspector or in the Plate Setup tab prior to exporting to BeadLogic. So now I have created all of my gates and I will redisplay them. The next step is to display each of these populations as a histogram showing the reporter parameter, in this case PE. As with the naming of the analytes themselves, defining the reporter parameter can also be done in the BeadLogic Setup tab in PlateLogic. So here I have my histograms of each of the analyte populations. I will quickly change the parameters to show PE. And if at this stage the gate template was saved, then this displaying of the PE parameter will also be saved in the gate template. I am now ready to add my samples to a new plate in PlateLogic. Once I have created my new plate, I can change the plate dimensions to match the number of samples in my group, and then highlight the samples in the File Inspector and drag them into the plate. Now, in the BeadLogic Export tab, under the Layout panel, I can define my different samples. In this case, I will highlight the first 12 samples and define them as my standards, with a replicate value of 1. The remaining wells I will define as my unknowns, also with a replicate value of 1. Then, under the Analyte tab, I can define which analytes to export, define the reporter parameter, define the concentration units, and also rename the analytes if required. Finally, under the Standard panel, I define the expected concentrations for each one of my standards. To do this, I can simply type in a value and right-click to define the serial dilution factor. Once I have defined the concentrations for all standards for one analyte, I can copy and paste these settings to the remaining analytes. Now that the setup is complete, I can click the Send to BeadLogic button to perform the analysis in BeadLogic. Once the information has been transferred, click on the BeadLogic tab at the top of the screen to view the plate as defined in PlateLogic, with all definitions and in a format ready to perform the regression analysis.